Hello everyone and welcome to today's webinar, the new New South Wales Stage 4 and 5 syllabus for science, What to Look Out For, with Dr. Simon Crook and lead science publisher Sarah Fabris. My name is Caroline Poole and I'm the New South Wales Field Sales Manager here in Sydney. Before we get started, in the spirit of reconciliation, Cambridge University Press and Assessment acknowledges the traditional custodians of country throughout Australia and their connections to land, sea and community. We pay our respect to elders past and present and extend that respect to all Aboriginal and Torres Strait Islander people here today. Our presenter today, Dr. Simon Crook, is a series consultant for the new edition of Cambridge Science for New South Wales Syllabus, Stages 4 and 5. Simon is an experienced science educator and honorary associate at the School of Physics, the University of Sydney. In 2015, Simon founded Crooked Science, a science education consultancy working with schools from all sectors K to 12 around professional development of teachers and working in situ and online with students. Today, Simon will be discussing the new New South Wales Science Syllabus and provide advice on changes that schools should prepare for. There will be an opportunity throughout the webinar to submit questions that Simon and our lead science publisher, Sarah, will address afterwards. But if we do run out of time for all the questions, we will definitely get back to you at a later time. So with that, I am now going to hand over to Simon to get started.
Thank you, Caroline. Hi, everyone. Great to be with you all. It's a lovely afternoon outside, but hopefully we'll be able to give you some answers about this new syllabus that is impending. Okay, there's a lot we're covering this afternoon. You would have read it in the blurb. I've actually just added a little bit more just in case we go through quite efficiently to get into some of the nitty-gritty on the content. But I've built that in as buffer, so I may skip that towards the end if the conversation takes up the time as we go along. So first thing, we need to consider it all, everything from a K to 12 perspective. Now, many of you will have seen this graphic from Stanisware, and they got their information from NESA back in 2023 even. Just very quickly, primary, I've got a new syllabus that is starting from 2027. Some schools have started already. They don't have to worry about exams. The key thing for yourselves to know is there are some fundamental changes, not least they're losing working scientifically, which personally I think is a shame because we currently have a K to 12 continuum of working scientifically. So they are getting what's called posing questions, which is greatly reduced from a skills point of view. So just be mindful of your year 7 differentiation from 2027 onwards, as students might be coming in with less skills, arguably. But also they may be coming with more content knowledge because that's more specific, and they should be coming in with greater writing skills because writing is part of the whole curriculum reform across all subjects. For the stage 6, which should be more relevant to most of you, the big thing to be mindful of is biology and physics being implemented in 2027. That means 2026, there's a lot of planning for year 11 bio and physics that may influence your decisions in terms of your planning and preparation for 7 to 10 science, which we're here for today. Now, judging from this graphic, 7 to 10 is implemented next year. Some of you have started this year, and there's been a real mixed message around when to implement 7 to 10, with some people getting quite agitated about what the message is or isn't. And I'll be honest, in all the PL I've been running, this has been the biggest conversation, and a lot of relief actually after we've discussed it, essentially based on some permission structures. So on that, I mean, the original message was, some people are saying that's everything 7 to 10 implemented in 2026 because that's what it looks like. If you called up certain people in authority positions, that's also the message they said. But when you dug down and dug down and dug down and finally got some definitive answers, the most definitive answer was ask your sector. So the department on their website published 3 possibilities. So there's some schools, well, in theory, are doing everything from this year. I only know of one school. That's actually a non-government school, and they did that for local decisions based on they knew they could get time for planning last year, and they knew that time for planning this year wasn't happening in their school for various restructuring reasons. So anyway, that's by the by. That's if you're already doing that, you might not even be sitting here if you have started. Although we're here to learn about what Cambridge is offering at the end of today. Number 2 and number 5 are what I would personally recommend. Although the overarching recommendation I make is your school context must essentially decide for you. But thinking, in general terms across most schools, doing 7 and 9 first, be it this year or next year, is easier on yourselves in terms of your planning. And then doing every grade the year after. So whilst you're teaching 7 and 9, you're planning 8 and 10. I did a bit of a canvas of teachers on the Facebook group, and there's almost like a 50-50 split between these two. Well, I say 50-50, they're like 43-43, and then a smattering of some hybrids in between. This option here, I think, is more for those smaller regional schools who might have stage classes teaching 7 and 8 together. I do know of some schools as well who've started this year with just year 7. I haven't added that into this graphic. But this was the original, almost like mixed message that came out. If you want to do that, you can do that. It is your prerogative to do that. But the really important message here is you do not have to do this. Okay, you can do this if you so wished. Okay, so different systems have got different directives or advice. Some are stricter than others. But for independent schools, by definition, you're independent, so you can make those local decisions there. But I know government schools who are making those 3 decisions, and a couple who are outside of these 3, and Catholic schools similarly within their diocese. You choose for yourselves. That's the really big message, and you are allowed to. And you can blame me if anyone says you can't. Okay. For those of you who are cross-curricular or have team members who work in other faculties, with all the curriculum reform after the curriculum review, a consistent structure was created, which kind of makes sense for efficiency. So we no longer have modules. If we think about the Stage 6 language, we have what are called focus areas. Every focus area has one knowledge and understanding outcome for the 7 to 10 science, and then some working scientifically outcomes that we'll come to later. You might be asking, where are the inquiry questions? Inquiry questions are no more. What were, if you think about where the inquiry questions were, that's now been called a content group. You may be asking, why are there no inquiry questions? The somewhat bemusing answer is the word inquiry is now taboo. It's a dirty word. Our malaise in Australian education, in our international rankings, and how we're doing so terribly, and it's all our fault as teachers, is apparently because of things like inquiry learning. Unfortunately, what the powers that be don't realise is inquiry learning in non-sciences is very different to scientific inquiry, which is the scientific method. Is it Robert Hooke since the 1600s, working scientifically, whatever you want to call it. Yeah, that's different to inquiry learning. So If you download everything, the phrase appears once in the syllabus, but the new term is content group. Now, you might think that's semantics. It doesn't matter. The reason why I'm emphasizing this is I know a lot of schools where inquiry questions work really well. They couch a whole subtopic. I know certainly for stage 6, a lot of people get their students to see if they can answer the inquiry question for, say, 5 marks as a practice question. So what I would say is, if in your school inquiry questions really work in your programs and you share those with the students and they couch that subtopic, then just engineer them back in. Okay, would be my recommendation there. And then within each content group, you've got your content descriptors, your dot points, listed as dot points. Now, NSW have tried to, and I'm not being facetious here, they've really tried to help teachers by removing a lot of the decision making that adds to teacher workloads. We have 16 terms across the 4 years, and we've got 16 focus areas to do in those 16 terms, which is lovely, beautifully symmetrical. I've seen this graphic given out as laminates in PL in schools. This is the recommended scope and sequence from NSW. It then begs the question, is it mandated? Do you have to do it? And again, when you push on this, you get different answers. But by definition, it can't be mandated. One, you could be a stage school, like one of those smaller schools. Have stage classes. 2, you might have quite an integrated STEM program with science and technology and maths and all integrated in. So you've got to work within those other faculties. But 3, it's, as professionals, it's our prerogative to decide what is best for our students. Now, I am not recommending that you do differently, but I am saying you can do differently to a degree if you so wish. I reckon 90% of the state will follow this, and certainly early doors whilst they find their feet, but then they might adapt things as things go along. Now, resources will be structured like this in this sequence. So I know for Cambridge, the resources will be structured in this sequence. I reckon for all the other textbooks that'll be out there and online resources, certainly from the departments, they'll be coming out like this. And I think even in terms of a flow from conversations I've had with Sham, although I don't wish to talk out of turn there, but most people will be structuring, and it seems logical to structure it so in this order, at least for those who are providing resources for many, many schools. If you did want to do things differently, or why you might want to do things differently, just want to highlight a few things. First off, observing the universe and change are what I call hybrid units. Observing the universe is a little bit of a misnomer. This is really intro to science plus a little bit of astro. Now, the intro to science is great because we're now being paid within the syllabus for what we always do in terms of that year 7 learning the skills, how to be a scientist, getting your Bunsen burner license, all of those things. The astro is completely separate. It doesn't have to be there. If you did want to have a bit of a rejig in stage 4, the astro part you could move to somewhere else. I'm just saying that's a possibility. I'm not saying you should. NSW recommend you teach in this order. It's been structured to be kind of increasing in rigor and logical in its progression, so they have designed it that way. But if you so wish and you want to do it differently, providing you don't move things across stages, you could do a rejig. One rejig I have heard of that's quite desirable for some schools is after doing the whole intro to science and lab skills, they want to go into term 2 to do solutions and mixtures. Because let's face it, your new year 7s, they think science is mixing potions, as they call it. So we have to teach them the chemicals. but lab coats and explosions and goggles and glassware and all that. And so, but a nice application of the skills might be to go to solutions and mixtures. That being said, there's a lot of experiments in forces, of course. Change is an interesting hybrid because it's kind of three disparate content groups shoved together. So we've got energy transfers, geological change, and chemical change. So they don't really link together apart from the common theme of change. That could be useful because if you did want to do some rejigging, that's three pieces of the jigsaw that you could do some rejigging. Just a quick thing, jumping over to stage 5. Waves and motion in many jurisdictions and previous syllabuses, these would be two separate topics. Okay, so to fit that all into one term, that might be quite difficult. Some people may want to carry over and perhaps, let's say, use motion as a context for data science too, just to get through all of that content. Arguably, you could say the same for genetics and evolutionary change. So just a couple of things that have come out in all the PL that I've been running. But the big thing to consider for the scope and sequence is data science. So we've got data science. It's new in terms of as focus areas or modules. Obviously, we've been using data in science teaching since forever. But this is presented as a whole term focus area at the end of year 8 and at the end of year 10. Now, some people are thinking, fantastic, we got something for year 10 to do that's kind of like meaningful. We can maybe blend it in with depth studies that we'll talk about in a minute. We can have a whole big fun personalized project. We'll do a little bit that counts the reports, but most of the reports will have been done, most of the work for the reports will have been done earlier in the year, let's say. So, people have got differing opinions about that. But equally, some people might think, well, we want our students to have data science skills earlier in the stage so they can apply them throughout the stage. Now, I believe the departments have actually got one suggested model for data science 2 to be split into 2 halves to bookend year 10, as an example. Now, again, I would say it's your prerogative. And I'm probably kind of stealing my thunder from a future slide to come. But the key thing is this. If you, I'll tell you what. I'll say what I'm going to say in about 3 slides' time, because then it will make a bit more sense. Just very quickly, so for Data Science 1, we have data, which I think, there's overlap there with cyber safety and perhaps what students might be doing within PDHPE, so have conversations there. This could definitely be part of some kind of standalone. Collecting, using, and analyzing data sets, I think this is going to be the most fun part, arguably, particularly if students can really personalize it. Now, this could be within scientific contexts, or it could be around their own aspects of interest, their own hobby, be it sport or, movies, pets, anything they liked there. So I think those two definitely, really could be as nice little standalones, let's say, at the end of year 8. Scientific models and applications of models equally could obviously fill up, half of term 4, year 8. But this is our bread and butter stuff. We'll be essentially doing scientific models and applying models throughout all the contents prior in stage 4. So the opportunities to integrate are kind of like quite obvious, if you so wish. Data Science 1 in context. Now, every single focus area has an in context, but so creating a model. Now, obviously, that can be a physical model. We often make physical models within science, but don't forget this could be a computer model, getting the kids coding. Or perhaps they might have some choice in terms of how they make models. Could even be mathematical or graphical models, which I think is quite empowering. Okay, so we can choose locally which context we want to focus in on. Data science 2, okay, so down for term 4, stage 5, ostensibly. So this as a collective, I think, is really looking to shape students up for stage 6, investigating science and science extension. Okay, so this again could be done as standalone in term 4, or we could have some integration. So, you know, we've got the very heavy kind of working scientifically, like next level skills, particularly, you know, as I say, with investigating in mind. So that could be integrated in. I think pseudoscience we can have a lot of fun with. Okay, getting kids to say what horoscope they are and saying, you know, what that means, you know, looking in the paper, what that says for them today. Then you ask what your horoscope sign is, and you say you're a dinosaur, and they go, well, that's not real. It's just kind of, yes. Anyway, sorry, bad dad joke. But I think we can have a lot of fun here. I think it's Carl Sagan who said every newspaper has an astrology section, but no astronomy section. Flat Earth theory, very big at the moment, a lot of conspiracy theories. But also, you may need to, depending on where your school is and your local community, you may need to be sensitive about some of the things you choose if you've got parents who work in alternative therapies, let's say, even if they are completely scientifically debunked. Just be careful before you call parents charlatans. Anyway, just be mindful there, but I think there's a lot of fun to be had. Large data sets are very much setting up for science extension. There's a lot of stuff in here and can have a lot of fun with causality and correlation, but some of us might need to revisit what we did for our bachelors, for our masters, or haven't done things before, like univariate and bivariate analyses. So some things to be mindful of there. Just with the in context, just talking more generally, a lot of the in contexts are quite generic, which again I think is empowering because it gives you the latitude to apply to a context of your choice. But in some of the contents, some of them are very specific. This is legislated. You just have to do what you have to do. Okay, now as a result of the curriculum review, and a big part of the curriculum reform is the emphasis on knowledge. The content is a lot more explicit. Okay, so, you know, the syllabus is essentially unapologetic in terms of the kids learning facts. There's far less vague, you know, woolly, grey kind of content points that may be in previous syllabuses. It's not 100% that. There are a couple here that are a little bit less specific in terms of perhaps their examples, but for the most part, they are a lot more explicit and most definitely a lot more rigorous. So in this syllabus, there's basically current stage 6 content in stage 5 and possibly even in stage 4, and certainly some current stage 5 content that is now in stage 4. 1 or 2 examples of flipping the other way, but by and large, it's far more rigorous, and that was a conscious decision for all the new syllabuses in all subjects. Okay, so depth studies. Now, at first reading, this causes teachers anxieties. Please don't be made anxious by this. So yes, you will now have to do 1 depth study every year. Don't be freaked out by that. It is not meaning you have to do a massive SRP type investigation in every year. I know some schools do that anyway with the current syllabus, but you only have to do one per stage. You have to do something that is labelled a depth study every year. But now, this is essentially preparing students for stage 6. This is depth study light. And again, there's a lot of flexibility here. It's not onerous. So they're recommending 5 hours of class time rather than mandating. So you've got flexibility there. But again, it's that preparing for stage 6. In terms of that equivalent to the current situation with 1 SRP per stage, you have to do at least 1 prac depth study per stage. If you've got a gun SRP practice at the moment, you could essentially repackage that as your prac depth study per stage. I know NEST are very conscious that they don't want people just carrying on business as usual. This is the time for reform, but absolutely, just talking as a fellow professional, don't throw the baby out with the bathwater. If you've got gun practices, you keep those gun practices, providing you're working within the parameters set out within this new syllabus. At least 2 working scientifically processes should be covered, but they're not specifying which. So again, depth study light if we think about stage 6 at the moment. And this is, again, just the empowerments that we have. A depth study may include a prac or series of pracs, secondary source investigation or a series of, or presentation, research assignment, or fieldwork report. Now, if your assignments are a bit tired currently, which I would guess would be for some people, that just is the case, this is your perfect opportunity to revamp some of your assessments. However, as I said before, from an SRP point of view, but just with some of your other assessment tasks, if some of them are absolute gun, but fall into, say, that presentation, research or fieldwork kind of category, you can then label those as depth studies. And I've just realized there's one, oops, I won't go back through the transitions. There's one important thing I forgot to say about data science. I said I'd wait and then I forgot. If you are going to integrate data science, you are going to have to keep almost a parallel scope and sequence of data science, or essentially a time log, because it is legislated that we have to teach everything. It's legislated that that's a term's worth of work. I believe NESA are extremely worried about the notion of integration, and I know some school sectors are as well. When we integrate things, there can be a tendency that not everything gets done. If you are going to integrate, you're going to have to make sure that you can demonstrate that you've done the time, okay, on the depth studies. Oops. All right, working scientifically. Sorry, not on the depth studies, I meant on the data science. Working scientifically, now we've gained an extra working scientifically outcome. So we've gone from 7 to 8 outcomes because they've added the preliminary outcome of observing, the idea of the initial observation to prompt the question, okay, and also the science of the instrumentation, so to speak. So that's nothing new. You can even find graphics with this as a cycle, as a scientific inquiry, scientific method cycle. But that's just interesting to note. Processing and analyzing data, we already do. That's core key business within working scientifically and within science teaching. But obviously there's big overlap there with data science if we wish to integrate. So just highlighting those opportunities. Now, something I do need to highlight. This happened in the current primary syllabus, and now it's gone and happened in this syllabus. With the best of intentions, I believe, to reduce teacher workloads, each focus area has only had some working scientifically outcomes allocated or assigned, not all of them. So they're not saying you have to do all working scientifically outcomes every term. However, some of the allocations are interesting. So, term one, observing the universe. You've got your one, knowledge, understanding, outcome, and then we've got the initial observation, and then conducting investigations. Happy days. Okay. Then we go to forces, and you've got your knowledge and understanding. Then we've got 4 working scientifically outcomes: questioning, predicting, leaping to processing and analyzing data, and then problem solving. But there's no conducting. Now, I personally, yes, I've got bias. I'm a physics teacher. I don't know of a unit with more conducting experiment opportunities than stage 4 forces. Like every lesson could be an experiment. Now, NSW have a get-out clause in their small print. Teachers may choose to include additional working scientifically processes as appropriate. Just as a colleague and as a parent, actually, can I make an appeal? Can you make sure you add conducting into every single unit? Can we please be doing some conducting investigations? Because that's what kids want to be doing. So what's allocated is the bare minimum to be compliant, but I recommend you actually do more. Whether you list more in your blurb, in your report, in your programs, that's up to you. But in actuality, and I would make it explicit personally, can we do the conducting? Okay, now, just doing a time check, got 14 more minutes before Q&A. What I was going to do now was to go through some of the contents and just to highlight some of the key takeaways, and then get to give you a bit of a taster of what's to come from Cambridge, and then we're doing Q&A at about 1:45. So first thing to note for physics, there are only 3 explicit physics focus areas, unlike biology and chemistry where they have 4 explicit ones. Really, physics is 3 1/3 because when we look at change, we got that energy transfers in there. So there's only 1 or 1 1/3 in stage 4 and then 2 in stage 5. Okay. So a couple of key takeaways. Forces. We're talking term 2, year 7. Algebra. Now, in some schools, no problem at all. It's what you do already. Fantastic. In other schools, low numeracy schools, that might fill you with abject horror. Can I suggest, 1, you have conversations with your maths colleagues. 2, you're going to need a lot of scaffolding there, because that'll be quite confronting for some students. We've also got simple machines coming back in. This is back to the future. So all your old resources on simple machines and all your old equipment and pulleys and levers and gears and all the rest of it, drag it out, dust it off, it's back in action. Okay, so that's why as science teachers we hoard things and don't throw away textbooks and the like. Now, in another explicit part of the new focus areas and new content, there is a lot of Aboriginal and Torres Strait Islander people's content. Now, some of it I think is more straightforward than others. I think, and I kind of know, I think for all the publishers out there, this is the biggest new aspect of content where a lot has to be generated and generated authentically and ethically and sympathetically, and all of those things. I've got some others to highlight later that I think are more troublesome. I think, for this one, say things like the Woomera and looking at things there, that's what it's crying out for. With the idea of levers and things there, and obviously other examples besides, but something to watch this space on. And to do a lot of planning for as well. And then we've got, I've kind of mentioned this before, but just in terms of the in context. So this is quite a flexible one in terms of the familiar context for forces and magnetism. magnetism, I would suggest, is a force. I think that's a legacy of, this was originally called forces and magnetism, and I appealed. That's a bit of tautology, and then they reduced it to forces. But I think that's a little bit of legacy still in there. Okay, energy. So in year 9, so we got the law of conservation of energy, which is great. A greater emphasis. I mean, for those of us who are physics teachers, if our year 12 students aren't mentioning that about 4 times in November's HSC, they're missing out on a bucket load of marks. So this is really ramping up and making preparations there. Something new is we're talking about closed systems. Strictly speaking, from a science point of view, for energy, it should be isolated systems. I did pose that. So it was suggested to me at a stage 5 level, it's still okay to use closed systems. Obviously, that's appropriate for matter, which we'll come to later. But I know it rankles a couple of people, but it is what it is. Just on this as well, energy transfers is, we're going to get to later, but that is in stage 4. We can't merge stage 4 and stage 5 unless you're in a tiny, tiny school. Some people would like to bring those together. Well, we're just going to be doing aspects of energy in both stages. I've mentioned that. Energy sources, just want to mention very quickly, common misconception is between types of energy and sources of energy. So again, might need help with, like if we've got retraining colleagues, non-specialists, that is often a common misunderstanding with students. So just be mindful of that in your resources. And then waves of motion, late on in year 10. Now, please be careful with this one. This screams out to the Western mind, let's do didgeridoos. But in most language groups, didgeridoos can only be played by males. So we're going to either, A, possibly, if we brought them into class, disenfranchise half the class in a co-ed school, or B, be incredibly culturally insensitive by letting anyone and everyone play a didgeridoo. I recommend you go through your Indigenous liaison officer or find your local elder and liaise, and let's deal with this authentically and sympathetically. But yeah, that's in the primary one as well. I was hoping they were going to fix that, but just be careful. Vector analysis, a traditional stage 6 bit of content, and that has snuck into stage 5. Now, I know some schools do vector analysis, but other schools might be freaked out by that. What I would say is, if this is year 6, stage 6 content, let's teach it with stage 5 pedagogy, get FET, get the vector. I mean, they're only saying 1 dimensions, get the vector sim, and then putting arrows end to end is very easy, quite engaging for the students as well, nice and straightforward. And you could extend the students by going 2-dimensional because it's very easy with the simulation. Other thing as well is all the equations, and representations. I mean, this is essentially SUVAT, equations of motion, if we follow this through for all of these quantitative relationships. So you might need a lot of scaffolding with your students for that. But obviously you can extend your top students quite nicely and prepare them for stage 6 there. At the very least, I'd push them on this equation here, get all students, core students, as far as this, and expand that, change in velocity being V minus U if you want to go there, identifying, or whether you use that algebraically or just in words, final velocity minus initial velocity, but expanding upon that. Okay, so as mentioned, we've got 4 outcomes, sorry, 4, well, we do have 4 outcomes, but we've got 4 focus areas for chemistry, so 1 in each year. I'm going to have to whiz through quite quickly just so I can get to the Q&A in time. So I do apologise to some of the other subjects if I think if I'm short-serving them, and I did physics first because I'm a physicist. It wasn't actually the reason. It's just the way I normally do things, which is probably some implicit bias. Just solutions and mixtures. This is just a quick appeal. Can we please double check our resources about the particle arrangements of matter? I've been offering this feedback because if you go and Google, for the different states of matter, we get some really horrible diagrams like this and this, where liquids are just an average of a solid and a gas with lots of big spaces between them, and therefore you can compress liquids. That is not the case. You can't compress liquids. That one there is absolutely horrible. The particles and liquids are essentially touching very close together. You can't compress liquids. That's how our brake lines work, but they take the shape of the container. Okay, and their particles can slide past each other. So watch out for that. There's a bigger emphasis on water and perhaps new things like buoyancy and surface tension in there. Periodic table, we got alloys as a bit of an extra focus in. Higher contents coming down into stage 4. Again, I would teach this stage 4 pedagogy. I'd jump straight to FET, build an atom, beautiful. You can add protons, add neutrons, add electrons, see how that changes the elements or the isotope or the charge, whatever you want. Materials. So, actually, sorry, my transition didn't work there. So we got a very nice Australian focus, okay, which I think is highly appropriate for materials, not least where a lot of our wealth comes from, both from a mining point of view and from an indigenous point of view in terms of minerals and the usage there. What I was laughing at was just a whole great big chunk here. This is Module 7, current Module 7 HSC Chemistry Light. This is, organic chemistry. So starting early there. Please don't upset your chemistry colleagues by giving Year 9s all the Molly-Mod kits. Double check with your chemistry colleagues. Cocktail sticks and blue tack or Play-Doh are sufficient. And so you can keep Molly-Mods for stage 6 if you wish. Reactions. Sorry, I'm getting a bit laggy here. So this is one of the few examples where there's a reduction in the number of chemical reactions suggested. Okay, so we're missing a couple there, and I'm having a mental block as to which ones we're missing. But yeah, so combustion, corrosion, okay, explicitly aren't in there, but something to be mindful of. And then we've got some intro to Mod 8 physics coming in. But I think some great opportunities there to talk about, everyone's drinking a glass of water. Well, kids got their bottles of water there. Well, what's water? H2O. When was that hydrogen made? Well, that was 13.78 billion years ago at the Big Bang. Essentially all of the hydrogen in the universe, including the water we drink. Okay, getting into bio. Sorry, all of a sudden I've developed some lagginess here. Okay, that didn't appear. We've got, again, a lot of Australian focus, which I think is excellent in this new syllabus, not least when you start talking about classification. I mean, Australian fauna are so unique. And then some lovely, some wonderful indigenous content there as well. Living systems into Year 8. Quick points here. You'll notice the musculoskeletal system isn't there. So you can do it as extra, but you don't have to. And the reproductive system isn't there. Now that caused some consternation in some schools. We do have sexual reproduction later, but more at the cellular level. In PhD, they look at sexual health. But in terms of the biology of the reproductive system, it isn't actually explicitly there. If you want to do it, that's going to be extra. Okay, so very important inclusion based on recent history. And this is also looking like stage 6 biology light. Lots of emphasis on data, opportunity for data science, genetics and evolutionary change. So yeah, this is where we've got the genetics around sexual reproduction going on. Also note that we've got asexual reproduction in there. I love the inclusion of megafauna. I think students find that absolutely fascinating. Again, we're going to have to be careful in terms of, say, copyrights and using Indigenous art appropriately. So just be mindful there, but that's often for the resource developers to kind of worry about, so to speak. And then here's one of the more explicit in context. We've got the HeLa stem cell line. Now, I'm going to whiz through this because I might just reduce some of my question time here because, sorry, this is important. Nature of science and practice of science. This is your intro to science. This is kind of like, you know, what is science? If you have your year sevens timetabled, sometimes in a lab, sometimes out of a lab, teach these two in parallel. Teach this outside of the lab. And if you're going to be inside the lab the whole time, I would even start practice of science. This is what the kids want to do first. I'm not going to really talk about these things, but you know, the astronomy is reduced. That's something to be mindful of there. Here we got energy changes, and again, looking at energy, types of energy. We got some, got to be thinking also in terms of systems, and very nice biochemical application of chemical change here. And just some interesting points in here. This is your Rube Goldberg machine down here, and I'm almost finished. A lot of climate stuff. We can now say climate change is in the syllabus, unlike the current Earth and Environmental Science syllabus where it isn't. So that is awesome that we've got that. So, Cambridge, just a few very quick slides here. We have got a lot of stuff focusing in on data science within the skills, a lot, and a big focus on the skills, full stop. This is taken from the skills from working scientifically. We've also got the review questions at the end of each chapter, and chapter reviews for the students to kind of like tick off. A lot of questions, and a lot of questions integrating data. So if you did want to integrate data. More checklists from a practical point of view, and new content, particularly in, say, new areas like, say, pseudoscience. And sorry for going a couple of minutes into, only 2 minutes into the questions. But yeah, we're up to the questions.
All right, thank you, Simon. That was a really good presentation. I'm sure everyone got a lot out of that. So that was really good. Thank you. So I'd now like to introduce our lead science publisher here at Cambridge, Sarah Fabra. So she, alongside with Simon, will be answering some of the questions that you have all sent through. And like I said in the beginning, if we run out of time, we will get back to you at a later time to answer these as best we can. Over to you, Sarah. Thank you.
Yeah, thanks, Caroline, and thanks so much, Simon, for going through the syllabus in that much depth. I think that's going to be helpful to all of us that are here on the call. Cambridge included, we're all continuously learning as we put everything together for this syllabus, which has been pretty exciting. So, just having a look at some of the questions that have come through. So, we've got a bit of a split between. So, Simon, there's a few questions for you about the syllabus, and then there's also some about our resource that's coming out this year that I'll answer. So, I might just flick a couple to you first, Simon, about the syllabus. So we did have a couple coming through. So one from David about the whether or not the focus area is being one term, if it's explicitly stated that it's expected to be one focus area per term. He's just commented that there seems to be, it looks like some of these focus areas contain more content than others. And it's just a bit of concern around that.
Yeah, look, it's designed that way. I don't think it's explicitly written that way. I think the greatest concern is around data science because it's new. It's something they're rightly proud of, and they're worried in case it's, integration means it's not actually addressed. Look, I agree. I think waves and motion, as an example, would require more time. And look, scope and sequences we haven't really spoken about, but if you've got school camps, if you've got shorter terms, if you've got whatever disruptions within your calendar, you've got exam blocks. Okay, I mean, you have to work within your school parameters. So I would suggest that those decisions perhaps might decide how you rejig things within a year or within a stage, perhaps because just the lengths of your how much teaching time you have in your term for whatever disruptions you have, whether you go over a term, might be one or two examples where you might have to do that I've kind of maybe suggested before, but I would make that the context for, say, the data science if you were to do that, just to cover yourselves.
Yeah, great. Thanks, Simon. And there was one more I'll just bring up about the syllabus. So one person mentioned, I know you said in your presentation you'd like everyone to emphasise the conducting investigations, work in scientific outcome in every area. They're also just commenting that if there's a requirement to do 50% practical anyway, they probably would be by default covering quite a lot of the conducting.
Well, yeah. I mean, and look, good teaching practice, you would do it anyway. So it's just interesting when it's not listed there as one of the outcomes. So I think if we can all agree as a state, let's just default to always include conducting, because you kind of have to anyway, do that. But for those that say we don't have to do it, on paper, no, you don't. But almost like ethically, I would suggest you do. Certainly pedagogically, you have to.
Yeah, great. Thank you. All right, so I'll move on to the resource. And I suppose just commenting on that too, that in part of our teaching programs and the resources that we supply to teachers with our Cambridge resource is fairly clear scope and sequences where we do actually map to all of the work in scientifically skills and where they're covered throughout the resource. And some of that does end up being quite obvious. So things like conducting investigations, you would expect most of the practicals would cover that. And it is referenced there, so you can kind of see where it all maps to. So there was a really specific question about the textbook. So someone's asking, are the solutions to textbook questions human-generated and edited because we're experiencing a higher rate than ever of errors and inaccuracies, especially with mathematical-based questions like physics in textbooks that are coming out? Yeah, so I understand why you would want to ask that as well. So our books all are completely human-written. We don't use any AI generation for creating questions and answers at the moment. So essentially any questions that are in our textbook are written by the authors, and the authors also write the answers at the same time. And then as it goes through our editing and answer checking process, the questions and answers are all edited continuously together. So they're sort of kept together right at the end, and then they're taken out so that the answers don't appear in the book, but they have actually been very, very clearly kind of checked all throughout at the same time. So there was one more question here about the online platform, just asking if it's similar to Cambridge Maths. So yes, that's an easy one. So yes, it is. So our online platform is Cambridge Engine for science and also for our humanities titles. So this is built on the same platform that powers Cambridge Hot Maths. So if you have taught maths or you've got colleagues that teach maths and you have used that before, it is the exact same platform. Essentially, it's the same learning management system. It's got all of pretty much all of the same reporting functionality, workspaces for questions, all of those sorts of things. So that's all in there.
Sorry, just on that, Sarah, it's remiss of me. I did originally have a couple of slides on the online platform, like some screenshots, and then in adding all that extra content, I think I must have knocked them out. So apologies.
No, that's all right. I think some people might have been looking through what we've got on our landing pages as well. So yeah, if anyone is wondering, so the print book comes as a package. So all of the student textbooks come with a subscription code in the front for the student resource, and then there's a teacher subscription as well that includes essentially all of the textbook features that the students get, plus all the teacher resources. So all the planning documents, downloadable tests, and all those sorts of things. All right. How are we going for time? We've got a few more minutes, so we can get through a couple more. Okay, so we do have one more that's come through on the syllabus, Simon. So Alison is saying that it would be useful on a compressed curriculum to have an idea as to which focus areas will take the least amount of time, and that way we can supplement those areas with data science or depth studies to bulk them out.
Okay. Ooh. So definitely not genetics and evolutionary change or waves and motion. I'm just having a quick revisit. Yeah, look, they're quite loaded. I think what I would say is there are some topics that you might currently actually do even more in, and there's kind of reduced content within the syllabus compared to how you teach. And I've been working with a lot of individual schools as well, and a lot of them have been saying, we actually do this stuff currently as extra. It's not in the current syllabus, or it's the extension material in the current syllabus, and now it's core. So it might be worth comparing against your current programs and what you teach and what's expected in this new syllabus. And then, because then you've got the experience of having taught your current syllabus or your current programs and how much time that takes to get a bit of a sense there. So really and truly, apart from a few of the year 7 ones, they're all quite loaded, depending on how in-depth you want to go.
Yeah, great. Thanks, Simon. All right, so I think we can squeeze in probably 2 more questions about the textbook. So I can see Levi's asked if the textbook provides a pathway for embedding the data science focus areas into the other focus areas, or is it provided as a separate topic? So yeah, it's a really great question, particularly around all of this discussion on whether or not data science would be taught separately or integrated. And as Simon said, obviously there's some opportunity to do either one of those or possibly a blend. So our textbook is set out so that there are separate data science components. There's a guide at the back of the book in an appendix, which does include some of the explicit curriculum content, but also provides kind of like a general guide to both teachers and students on how they can approach that topic in different ways. But it is also more than anything integrated throughout the whole book. So as Simon showed in some of those slides at the end, that there are a set of data questions at the end of every chapter. So those will be questions that are relevant to the focus area and to that specific topic that the chapter covers, but giving them that practice of data skills and covering specific outcomes in that way. And then there's also sort of opportunities throughout in terms of digital resources. So we've got lots of worksheets that do a similar thing where it'll have a sample of data and it gives students practice in kind of interpreting that data, doing some calculations, using spreadsheets like Excel, all of those sorts of skills. So that's all included throughout as well. All right, so I'll go to one more question. I did see one here about, so I saw Joanne asked if the text is differentiated. So I suppose with that one, the differentiation we provide is largely in the sort of assessment and summative and formative assessment resources that we provide. The textbook itself, we do set out all the question sets with Bloom's taxonomy, so it's all sorted into lower and higher order thinking, so that it can be split between students as needed. The other thing we do is that we actually have leveled questions in all of our worksheets and tests, which are available in the teaching suite. These are all downloadable files, but essentially they all will have a little graph icon next to each question. It's very subtle, but the point of it is to show which questions you could classify as sort of a level 1 through to 3. And then you're able to just kind of distribute all of this to students and tell them things like just answer questions 1 and 4 if you want to do the low level ones, or other questions to do higher. So there's options throughout with that. The other major feature that we've added this year for differentiation is actually our adaptive testing platform. So adaptive testing is not needed at all for, there's no kind of preparation of identifying which students need the higher or lower challenging questions. It automatically adapts to every student. So this is essentially just a test that you can assign to all of your students in the platform without having to customize anything. And then the test, depending on whether they get questions right or wrong, will actually show different students an easier or a harder question. So I won't go into detail in that now, but if anyone's interested or wants to understand more about how that works, certainly get in touch with Caroline and the New South Wales sales team, and they can talk about that in a little bit more detail. I think we're right on 5, so I'll hand back over to you, Caroline.
All right. Well, a big thank you to you again, Simon and Sarah, for today's webinar. So just before we finish up, I'd just like to share a few details of the New South Wales sales team on the screen. So please feel free to contact either one of us with any further questions in regards to availability and pricing. We'd be more than happy to come out to the school, run through some samples, do a demonstration of the online platform as well, and just help you further with any questions. There's also a URL there that you'll see, so that will take you to our website. Now, this is regularly updated with different bits of information and sample pages, so please check in with that, and you will find more information pop up as you do. And that is it. So thank you for all joining us. It's been a really good webinar. I hope you've all gotten a lot out of that. And on behalf of the team, have a great night.